So today I am going to discuss other beta-lactams and beta-lactamase inhibitors. So under the other beta-lactam antibiotics, there are only two groups are coming. One is called carbapenems, another is called monobactams. That means that these two are also possessing the beta-lactam rings. Under the carbapenems, the antibiotics comes are imipenem, meropenem, ertapenem, and under the monobactams, the antibiotic comes known as H3onam. So why they have kept this under the other beta-lactams antibiotics? Because the beta-lactam antibiotics, which include penicillin and cephalosporin, are somewhat differ from these other beta-lactam antibiotic. What is the difference between these? The difference is that the resistant bacteria releases the enzyme beta-lactamase, which usually destroy the beta-lactam rings of cephalosporin and penicillin. However, the beta-lactamase released by resistant bacteria are usually not able to destroy or hydrolyze the beta-lactam ring of carbapenem and monobactam. So this is the difference. So now we have to go through the carbapenem. So first we have to go through why the name is carbapenems. The silent feature of carbapenems are this is also possessing the beta-lactam rings. First point. Second point is that why the name is the carbapenems. The name carba is indicating the carbon. So this carbapenems possessing beta-lactam rings as well as the another ring that is fused with beta-lactam rings. So the other ring in case of carbapenems attach with the beta-lactam rings, they possess carbon in place of sulfur. That is why the name is carbapenems. So carbapenems is indicating presence of carbon in place of sulfur, the ring attached with the beta-lactam rings. So that is why the name is carbapenems. Other important point with this group is that here the name is carba, this means carbon, then penems. So usually the antibiotics that belongs to this possessing suffix penems, and that is why the name is imipenem, meropenem, ertapenem. These two drugs, imipenem and meropenem, are broad spectrum antibiotic. Why these are broad spectrum antibiotic? Because they are possessing activity against the gram positive, gram negative, as well as the anaerobes. Not only that, if these bacteria means gram negative and gram positive are releasing the enzyme beta-lactamase, this carbapenems antibiotic beta-lactam rings are not going to be destroyed. So this is very, very important. That means carbapenems are having beneficial point or beneficial effect is that their beta-lactam ring should not be usually destroyed by the beta-lactamase enzyme produced by the resistant bacteria. However, the resistant bacteria that belongs to metallo beta-lactamase enzyme, MBL. M for metallo, B for beta-lactamase releasing. So metallo beta-lactamase enzyme are usually going to destroy the beta-lactam ring of the carbapenems. N- However, the simpler beta-lactamase are not going to destroy the beta-lactam ring of the carbapenems. Only the MBLS. M means metallo, B for beta, L for lactamase. And that is the new one. The most prominent example is New Delhi MBLS. This is the new beta lactamase and that is the new entry. So under this the drug are that we are already discussed. The drug are imipenem, meropenem, ertapenem. So and other silent feature with this one is carbapenems is they all are parenterally administered drug. They are either administered by intravenous route or intramuscular route and the drug distribution are very well. That means drug are distributed in almost all the tissues as well as the body fluid. So drug has to reach everywhere in the body. So that is why this is also the important feature of the carbapenems. Under the carbapenems, as I mentioned, the drug are coming imipenem and meropenem. These two are most usable carbapenems. That is the imipenem and the another one is the meropenem. So, what are the silent feature the imipenems have? The silent feature is that this one has been derived or synthesized from a compound isolated from actinomycetes streptomyces catalea. So, from this streptomyces catalea, one compound is derived and from this compound imipenem was synthesized and this imipenem is not going to be used alone. This imipenem is used along with cilastatin. So this is very very important कि imipenem is coming in combination with or in compounded with cilastatin. So the reason behind that we are going to discuss. Why? Because the renal tube has an enzyme dipeptidase and this dipeptidase is also known as dehydropeptidase. So where this enzyme is present? This is present in brush border of renal proximal tubule. So what is the name of enzyme this? This is the dipeptidase or dehydropeptidase. So what is the function of this enzyme? This enzyme is going to metabolize the imipenem. So the imipenem get metabolized within the kidney and after the metabolism of imipenem, this imipenem form a toxic metabolite. So because of the toxic metabolite formed by this imipenem with the help of dipeptidase, this drug become their metabolite become toxic and therefore we have to use such type of drug which is going to inhibit the imipenem metabolism in the kidney and therefore to inhibit the metabolism of imipenem by the enzyme dipeptidase, a dipeptidase inhibitors are used. So cilastatin is a dipeptidase or dehydropeptidase inhibitor. Therefore, imipenem is not going to metabolize to form a toxic metabolite. So that is why the imipenem is used along with or compounded with silastatin. So this is the reason the imipenem is. So as I earlier mentioned, carbapenem is used along with silastatin and usually for parenteral administration. Regarding mechanism of action is concerned, the beta-lactam antibiotics are possessing the same mechanism of action. Means that they are going to inhibit the enzyme, and as a group we are calling it the PBPS. P for penicillin, B for binding, and P for protein. And S means number of enzyme. So these beta lactams are going to inhibit the enzyme. We are going to call it the penicillin binding proteins. Amongst that enzyme, most important enzyme is the transpeptidase. So therefore it inhibit the transpeptidation. That means ki they inhibit the cross linking formation of peptidoglycan. So that we already discussed. So here we are not going to discuss much, but imipenems or carbapenems as a group, the similar to the beta-lactam antibiotic inhibit the enzyme penicillin binding protein, which include transpeptidase, and therefore inhibit the formation of cross-linking of the peptidoglycan, and therefore it inhibits the cell wall synthesis, and therefore bacteria is going to die. So this is a bactericidal antibiotic. Now we have to go through the antibacterial activity of imipenem. So imipenem, as I earlier mentioned, is the broad spectrum antibiotic. So this is the broad spectrum, and not only that, they are beta-lactamase enzyme are not acting on the beta-lactam ring of the carbapenem. So that is why this is very, very important, because the beta-lactam ring of the carbapenem persists even in presence of beta-lactamases like penicillinase and cephalosporinase, except the MBLS that I earlier mentioned, that is the new entry like New Delhi metallo beta-lactamase. So this is the important. Antibacterial activity of meropenem is similar to the imipenem. So this meropenem should not be discussed much more. So regarding the that I earlier mentioned, the beta-lactamase enzyme are not going to destroy the beta-lactam ring of carbapenems like imipenems and meropenems. Therefore, these carbapenems are called beta-lactamase resistance, because their beta-lactam ring are not going to be hydrolyzed by most of the beta-lactamases released by resistant bacteria, except the new entry, that is the metallo beta-lactamase, that is the MBLS, that is the, and among this the example is New Delhi metallo beta-lactamase. So this is important. This is not only that, these carbapenems like imipenem and meropenems are showing activity against the penicillinase, that is a beta-lactamase enzyme, is not going to destroy the beta-lactam ring of the carbapenems of gram-positive bacteria, gram-negative bacteria, anaerobes, and Pseudomonas aeruginosa. Therefore, carbapenems are going to produce activity against these bacteria. Regarding pharmacokinetic property of this one is concerned, I mean the carbapenems is concerned, imipenem, meropenem, as I earlier mentioned, is coming in the form of parenteral administration, particularly for intravenous administration. As I earlier mentioned, they have the well distribution, so it will find in the most of the tissue of the body, as well as it also found in the body fluid. Not only that, if the membrane of the brain, that is the meninges, is inflamed, the drug is cross that BBB, and it reach in sufficient quantity in cerebrospinal fluid. So this may be one of the choice for the treatment of meningitis. Regarding excretion of the carbapenems is concerned, as we earlier discussed, that cephalosporin as well as the penicillin, the excretion is by mainly tubular secretion as well as the glomerular filtration. However, the carbapenem's main route of excretion is by kidney through glomerular filtration. So there is no involvement of tubular secretion. So this is important here. This is very, very important. Next point is that I earlier mentioned the imipenem, only imipenem, not meropenem. This imipenem is used along with the silastacine. Why? Silastacine is this dipeptidase enzyme inhibitor. So there is no metabolism of imipenem, no toxic metabolite. So therefore, imipenem is used in compounded with the silastatine to inhibit the formation of toxic metabolites. And therefore, this may be the one of the drug to be used for the therapy of urinary tract infection. So this is about the imipenem. Meropenem is not going to produce such type of metabolites in the kidney. So that is why the meropenem is not coming with the silastatine. Next and the last drug under the carbapenem is the ertapenem. Ertapenem, their antibacterial activity is not like the imipenem and meropenem. The antibacterial activity is not like the imipenem and meropenem. But what the benefit this ertapenem have, their half-life is more. So because of the half-life of this drug is more, this drug should be used once daily. So this is very, very important point. So the last one under the carbapenem's drug is the ertapenem. One more drug is there under the carbapenems is doripenem. So there are four drugs under the carbapenems are imipenem, that is used along with the silastatine, meropenem. These meropenem and imipenem, their antibacterial activity are quite similar. So these two are the mainly used drug that belongs to the carbapenems. However, the ertapenem and doripenem is not much in use. However, ETA is used because of the long half-life. If you want to require longer half-life, or you want to give once daily the drug, then ertapenem is also one of the choice. So in the this other beta-lactam antibiotics, we already finished the carbapenems. Another one, the monobactams. Monobactams have only one drug. And why the name is monobactam? Mono means one. So this monobactam, why the name is monobactam? Because in this monobactam possesses only one ring. That is only beta-lactam ring is there. So that is why the name is monobactam. And this drug have only one example, this group, and the antibiotic is aztreonam. So aztreonam is a monobactam, has been isolated from Chromobacterium violaceum, and as I mentioned, this one not possess the other ring. Like the other carbapenem, cephalosporin, penicillin have the other ring. Like the penicillin have the thiazolidine ring. Cephalosporin have the dihydrothiazine ring. Carbapenems also have the ring along with the beta-lactam rings. But monobacteriums don't have. That is why the only one ring is there. That is why the mono comes. So monobactam, an example as I earlier mentioned is tunam. And the mechanism of action, because this monobactam is also a beta-lactam, so the mechanism of action of this monobactam have the same like the other lactams antibiotics. So it disrupts the cell wide synthesis through the penicillin binding protein. So this is about the monobactam. Other features the monobactams like azithromycin antibacterial activity is concerned. Antibacterial activity of azithromycin is it is active against the Enterobacteriaceae, also against the aerobic gram-negative rods, including Pseudomonas aeruginosa. Aztreonam antibacterial activity is quite only concentrated on gram-negative bacteria, and that is why the Aztreonam antibacterial activity is quite resemblance with the aminoglycoside, because this is the only acting against the gram negative rods. So that is why their resemblance with the aminoglycoside. Usually they don't have the gram action against the gram positive bacteria. And anaerobic, likewise the aminoglycoside also poses the same feature. So that is why the H2 is comparable with the aminoglycoside. So this is also resistant to the beta-lactamase enzyme. That means resistant bacteria that releases the beta-lactamases like penicillinase and cephalosporinase are not going to destroy the beta-lactam ring of the osteonome. So that is why this is also important, and this is also for the parenteral administration like carbapenem. And likewise the same, the route of excretion is the through the urine, and this is one of the safe alternative for penicillin and cephalosporin in the patient who are possessing the allergic property with the penicillin and cephalosporinase. So you have to use in place of cephalosporins and penicillin if the patient is allergic to these two groups. So this is the alternative for this one. So this is all about beta-lactam antibiotics. So under the beta-lactam antibiotics, we have discussed the penicillin, we have discussed the cephalosporins, we have discussed the carbapenems, we have discussed the monobactam. So this is all about the beta-lactams. Now we have to go through the beta-lactamase inhibitor. So try to listen it carefully, and this is very, very important and interesting. So what is the name is? Name is beta-lactamase inhibitor. What? Inhibitor. To which enzyme? Beta-lactamase enzyme. So those drug or compound that inhibit the action of beta-lactamase enzyme released by resistant bacteria are called beta-lactamase inhibitor. What it means? It means if you are using beta-lactamase inhibitor, then this is beneficial for those antimicrobial agent of beta-lactam antibiotics that are sensitive to the beta-lactamase enzyme. So under this beta-lactamase inhibitors, the drugs are coming clavulanic acid, sulbactam, tazobactam. So these all are called beta-lactamase inhibitor. So what it means, usually these compound is coming with the penicillin or cephalus penicillin mainly. They are usually coming in combination with the penicillins that are sensitive to the beta lactamase enzyme. So what will happen if a penicillin like ampicillin, amoxicillin, ticarcillin, piperacillin, these all are the penicillins. They are sensitive to the beta-lactamase enzyme released by resistant bacteria. So the beta-lactamase enzyme that are going to destroy the beta-lactam ring of these antibiotics that I earlier mentioned. What? The ampicillin and amoxicillin and ticarcillin and piperacillin, their beta lactam ring are destroyed by the beta lactamase enzyme. So when you are using inhibitor, so these inhibitor are going to inhibit the enzyme beta lactamase. So therefore, when the beta lactamase enzyme get inhibited, the sensitive antibiotic like penicillin of amoxicillin, ampicillin, as such antibiotic remain there to act, and that is why they are coming in combination with the beta lactamase inhibitor like clavulanic acid. So when the beta lactamase enzyme is released by the resistant bacteria, they are going to destroy the clavulanic acid or react with the beta lactam ring of clavulanic acid, because these all inhibitors possessing the beta lactam ring, means clavulanic acid possess beta lactam ring, sulbactam possess beta lactam ring, tazobactam possess beta lactam ring. So these all are possessing the beta lactam rings. So therefore these enzymes are going to act on the beta lactam ring of the clavulanic acid or sulbactam or tazobactam. Therefore enzymes are not such remain there persisted to act against the main penicillin like amoxicillin, ampicillin, ticarcillin, piperacillin. Therefore they act against the bacteria. So that is why we are using the inhibitors like this clavulanic acid, sulbactam, tazobactam. So now we have to see what are the combination that are coming. So here that you have to read here. Instead they bind to and inactivate beta lactamase. So what they are telling, these inhibitors are going to bind with the beta lactamase enzyme and inactivate the beta lactamase. So when the inactivation of the beta lactamase is there, the beta lactamase is not remain there to or not persist there to act on the main drug. So main drug is going to act against the bacteria. So therefore they are coming in combination with the inhibitor, therefore protecting main antibiotics, and that are substrate for these enzymes. Beta lactamase combination inhibitors in combination with the penicillins are amoxicillin plus clavulanic acid. So clavulanic acid is a beta lactamase inhibitor and amoxicillin is the main drug. So what is this beta lactamase enzyme produced by the resistant bacteria? They are going to act on the beta lactam ring of the clavulanic acid. So therefore the beta lactamase get inactivated, so they are not going to act on the amoxicillin. So amoxicillin as such remain there to act against the bacteria, and that is why they are coming in combination, and this is very good choice to use against the beta lactamase producing resistant bacteria. So amoxicillin is coming in combination with the clavulanic acid, and they are active against the E. coli that are producing the beta-lactamases. So these beta-lactamase is going to combine with the clavulanic acid. So beta-lactamase as such is not present there to inactivate the amoxicillin. So amoxicillin is active, remain there, and therefore they are going to kill the E. coli. So therefore this is very very important. Clavulanic acid is not only coming with the amoxicillin. This clavulanic acid is also coming in combination with ticarcillin. So ticarcillin plus clavulanic acid. Another combination is ampicillin. So ampicillin and amoxicillin is the very very most usable drug in combination with beta lactamase inhibitor. So ampicillin in place of clavulanic acid, this is coming in combination with the sulbactam. So ampicillin with the sulbactam, amoxicillin with the clavulanic acid, ticarcillin with the clavulanic acid, piperacillin is coming along with the another beta lactamase inhibitor, that is the tazobactam. So these clavulanic acid is called suicide inhibitor. Why this is called the suicide inhibitor? Because clavulanic acid itself possessing or all the beta lactamase inhibitor possessing the beta lactamase. However, the clavulanic acid a beta-lactam ring are destroyed by the beta-lactamase enzyme. So therefore, their entity of clavulanic acid is destroyed, and therefore this is called suicide inhibitor. And this is irreversible one. So this is all about the carbapenems, monobactam, that these two in combination is called beta lactamase, other beta lactamase antibiotics. And we also discussed the already discussed the beta lactamase inhibitor like tazobactam, then sulbactam, then clavulanic acid. So this is all about this one.